Thevenin. R Thevenin, like here you can see we have open source provided, and okay, open circuit provided, and here you can see this is an independent source. Whenever we have an independent source and an open circuit, what we can do is we can actually add a test source. You can either add test current source or voltage source. It depends on which one makes the life easier. Here, as I see, if I add a voltage source, it's going to make everything easier. So I'm going to go ahead and add a voltage source, test voltage. Let's put this one as a 1 voltage. 1 voltage. 1 minute. 1 second. Okay, this is our test voltage. And if you are putting a voltage, we have to find out the current through this. So let's call this one IS. Okay, so if we find the IS current, because if we input a voltage source and a current, RThevenin is going to be the voltage we input, that is 1 voltage divided by the current source. Now we know the voltage, we just have to find out the current. If we find out the current, we can find the RThevenin. Now to find out the current, you can see this node right here. In this node, if I take KCL, I can try to solve for this current. So let's apply KCL at that node. KCL says summation of current in is equal to summation of current out. Summation of current in is equal to summation of current out. And here we have only one current here, and also we know this current is IS going through this. Let's assume this current is going this direction, IX. You can assume any direction. So I'm assuming this direction. So if I do that, then IX and IS are entering this node. So this is going to be this side, IX plus IS, and I1 is exiting this node. So that's going to be in the other side, IS. Okay, now you can see we have how many unknown variables? 1, 2, 3. This is I1. Okay, this is I1. Okay, we have 3 unknown variables. So what we have to do is we have to just write this one in terms of voltage. So we can make this one unknown variable. Let's call this voltage right across this as V. So if I represent this one as V, then instead of IX, I can write this one as, because here this 20I1 dependent voltage source is actually plus on the top, right? We have plus on the top. It means the voltage here at this node is going to be 20I1. So this is 20I1 and this is V, and here we have IX. If I write the IX in terms of voltage, this is going to be 20I1 minus this voltage divided by the resistance in between, that is 10 ohm. And then that is that one plus, and IS is going in this direction. And also for the 1 voltage we input, we put a plus on top, minus on the bottom. So the voltage here is going to be 1 voltage right here. So if I write IS in terms of voltage, this is going to be 1 minus V divided by the resistance between, that's 5. Okay, that is equal to I1. I1 also I can write it in terms of voltage, because this is V and the bottom part is always the reference voltage that's connected to the ground. So this is going to be V minus 0 divided by the resistance between, that is 30. So I just put V over 30. Okay, now we have only one unknown. Oh, how many unknown variable? Okay, here we have I1 also. This I1 I can for I1 I can create an equation from this. This one is what? I1 is V minus 0 divided by 30. I1 is V minus 0 divided by 30. So I1 is equal to V over 30. So I can replace this I1 with V over 30. So 20 times V over 30 minus V divided by 10 plus 1 minus V over 5 is equal to 30. Now to get rid of all these denominators, okay, this one is V over 30 here. V over 30, and to get rid of all this denominator we can multiply both sides by 30. So if we do that, then this is going to become what? This is going to become 3 times, because 10 and 30 cancels, so 3 times 20 V over 30. You can also, it's better to simplify this one first and then apply. So here if I simplify this one, 2V over 3, we get 2V over 3. 2V over 3 minus V, and here we will have, if I multiply by 30, this is going to be 6 on the top, 6 times 1 minus V, and in the other side we're just going to have V. Let's simplify this one furthermore. Okay, we multiply everything, we multiply both sides by 3. Oh no, 30. I applied 30 for this one and this one 3 only remaining for this, so I'm just multiplying this 3 by these two only. This bracket is unnecessary here. Okay, 3 times this is going to be just 2 voltage right here, and 3 times this is going to be minus 3V, and then plus 6 times 1, that's 6, and then 6 times V, that is negative 6V, and that's equal to V. Let's add the like terms. So 2V minus 3V is minus 1V, minus 1V, minus 6V, minus 1V, 1 minus 6V, but that's minus 7V. And if I bring this V to this side, that's minus 8V. So this is going to be minus 8V right here, that's equivalent to minus 6. So therefore V is going to be equal to minus 6 divided by minus 8. Minus 6 divided by minus 8 is 0.75 voltage. Okay, now we have found out the voltage, but our purpose is to find out the current, IS. Okay, voltage is 0.7. Let's note this one somewhere here. V is equal to 0.75 voltage. Can I use this and find the current IS? IS is what? 1 minus V divided by 5, right? So let's write the equation for that. IS is equal to 1 minus V divided by 5, and V is like 0.75. 1 minus 0.75 divided by the 5. 1 minus 0.75 is 0.25. 0.25 divided by 5, 0.25 divided by 5, that's equal to 0.05. 0.05 milliampere, that's equal to 0.05 ampere, that's equal to 5 milliampere. 50 milliampere actually. 50 milliampere. Okay, now we have found out the current. Current is 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 50 milliampere. So R Thevenin is easy because we have that 1 voltage, and IS also we found out using this equation. Now we can plug it in this equation. R Thevenin is equal to 1 divided by IS, and that is 50 milliampere. 1 over 50. 50 milli becomes kilo when it goes to the top, so this is going to be 1000 divided by 50, that's equal to 20 ohm resistance. That's our R Thevenin. And that's it for this video, guys. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.